Hello and welcome to the second video on remote user authentication. In this video, we're going to discuss some of the general characteristics of the protocols that we're going to be describing in this lecture. So a protocol is just a set of rules between two or more parties that agree to communicate with each other according to specific rules. So a protocol in particular defines the syntax of each one of the possible messages, that is the format of the data that's represented inside those messages, and also the semantics of these messages, that is what they mean and the type of actions that the parties are supposed to take upon receiving those messages. The protocol also defines the synchronization mechanisms and the timing information as to not only the order in which the message must be sent, but sometimes the timing between the messages. And finally, protocols may include some error recovery methods, and so on and so forth. So, an example of a protocol in a human communication scenario would be when a student wants to ask a question of the instructor in a classroom setting. Typically, the informal protocol would be something like the student raises their hand, waits for the instructor to notice that they raised their hand, then wait for the instructor to call on them, and finally is allowed to ask their question. So this is a protocol in the sense that it's not expected that any student can start talking at any time over the instructor, say. Now, in the case of networking, we have protocols that, for example, lie at the top of the network stack in the application layer, like HTTP for the web, FTP for general file transfers, and so on and so forth. And then we have more security-focused protocols that live lower down the networking stack, say at the transport layer or the IP internet layer, such as the SSL protocol, the IPsec, and some other authentication protocols that are more specialized. So the thing to realize is many of these protocols have flaws, security flaws that can be very subtle. So there are many existing protocols, especially one of the early ones was WEP, that is riddled with errors, but even more modern and still in use protocols like GSM and for cell phone communications and IPsec in the general net IP, TCP/IP network stack that also have flaws. So the main thing to remember throughout this course is that either the protocol could be flawed in its design, or even if the protocol were perfect, which is basically almost impossible, there could still be implementation errors in the way that the protocol is actually implemented or used. So just keep in mind, no matter what, it is extremely hard, almost impossible to get a protocol that is completely secure. So what are the characteristics that in the best possible world we would want a protocol to have? Well, first, it must have very precise requirements, and it must meet the requirements that are set forth. So this is the assurance part of the equation that we don't talk much about in this class. Also, the protocol must be efficient in the sense that it must not overwhelm the system either by having too many computational requirements or too high computational requirements or too high bandwidth usage. So you don't want to slow down the whole system just for the security protocol. Of course, the security protocol ideally would be robust, which means that it should not only work in normal circumstances, but also when an attacker is trying to subvert the system. And also, it should still work when the environment of the system changes even slightly. So, this is very important because security systems are designed based on a threat model. And if the assumptions that the designers made about the capabilities of the attacker, that these assumptions are never completely correct. So we want to make sure the system still is secure even when those assumptions are slightly off. And ideally, the security protocol should be easy to implement, they should be easy to use, and they should be flexible and usable in as wide a set of circumstances as possible. Now, as you can imagine, it's difficult and basically impossible to achieve all of these ideal characteristics, especially because some of them, like this one, are already hard enough to meet in by themselves. So adding all of these constraints makes the problem extremely hard. So here is a brief overview of some of the topics we're going to be talking about in this lecture. So obviously we're going to reuse some of the cryptographic primitives we discussed earlier in the semester, including symmetric keys, asymmetric keys, and hash functions. We're going to be talking about scenarios where only one of the parties has to authenticate themselves to the other, and also mutual authentication, where each party has to authenticate themselves to the other. So here the question is, how many of the parties have to be authenticated? All of them or just one of them? And then we'll talk about the importance of session keys. So when do we need those? When are they used? And then the concept of perfect forward secrecy. What is it and how do we support it? So one thing to be aware of is now that we are done discussing the details of cryptography and the encryption, decryption algorithms and hashing algorithms, we're going to make the assumption that those primitives now are well designed, they're secure in the way they are designed, implemented, and their operational features, the way they are used. So in other words, the attacks we're going to consider now are attacks on the protocols themselves. But we're going to assume that the components of these protocols, namely these cryptographic primitives, are themselves secure. So it's important to keep those two levels distinct. When you're studying a protocol, you could have an attack that relies on the crypto being unsafe. We're going to ignore those attacks because we already discussed the security of cryptographic primitives. But another level is even if the cryptographic primitives are secure, it could be that their use of them in the protocol, that use of them is not secure or not safe because of the way the protocol is designed. So again, keep those two levels of security distinct and remember which assumptions we're making in each discussion.